Well, as the sign says, greetings and welcome to a short, sweet lesson on basic problem solving for the kinematic equations. And as you have an upcoming test, let's see what we can do about getting you ready for a review here. Now, there are certain expectations that you need to have on a video lessons, which is you will be able to stop and start, back up the lesson, and go over the materials. The normal pausing to write things down is not done since you have control of the video player. Otherwise, this thing takes 6 hours. Objective: review some basic definitions, solve simple velocity and speed problems, be able to expand the information from simple velocity problems to find additional items like acceleration, or what happens when the question gives you an item like distance and time in parts but not the total. Be able to solve the problems when time and or distance is not given from other items provided. So, let's review some definitions and concepts. The fundamental assumption of science begins with that there's one set of laws for the entire universe. And of course, that's going to be on the test. Scientific method, which is a systematic approach to solving problems, can be described using the acronym PREACH, though the actual order is PREACH, as you can see. Purpose, why this experiment or measurement is being done. Research, what is known about the experiment or the measurement before it's done, including citation. Hypothesis, your educated prediction of what will happen. It should be in a form that allows for yes, no determination or confirmation. For example, I predict the results will be within 5% of standard, can be given as a confirmed or not confirmed determination. Whereas I think the results will be good is too ambiguous, as what is good is not expressly defined. Flip this over. See what we got here. Experiment. This is the actual doing it part to test the hypothesis. All variables and materials and procedures go here. In many instances, if you have written instruction sheet, there's little to do other than copy. Analysis of data. This is where all the data is initially put, then it's analyzed. You should make tables with raw and analyzed data as appropriate. A separate section of calculations is where you demonstrate with sample calculations how each type of calculation is done and tell the reader where the information is found in the data charts. Results is where you explain the importance and demonstrate and understand what those numbers mean. So for an example, I have this paper, which I'm not going to tell you who it is. The person gives me some nice data here. Now, in the calculations, they should have told you how did they get the average, which was take this, 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 and this, add it up and divide by 6. So when they say calculation average was done by that, or when they said I wanted to know what my this list here, which was this minus that divided by 2, and this percentage would be this divided by that times 100. Here they have the average and same as the same percentage. I suspect there's a problem there, but I wanted you to see right and wrong. Lab questions are placed at the end of the analysis section with questions and answers. Let's see, we can rotate this. There we go. Conclusion evaluation. This is where you state as your hypothesis is either busted or confirmed and why. Then you explain experimentals such as uncertainties in the measurement, things that could or did not go well or went less than perfect. Now comes a description how you would improve or correct errors described in the prior items, the way Mythbusters does. When you do the next version, you make it better. Because the next time you do it, unfortunately, we don't get to blow it up. Sorry, we're in school. We have to leave that to TV. Last is where you summarize what you learn. And you go from there. Definitions. Distance. The space or length between 2 points. Going to be on the test. Displacement. The net distance and direction. That way we can get to the problem of the young lady who goes jogging, and she goes jogging at 10 kilometers an hour for 1 hour, and she lands back where she started. How far did she go? Well, one interpretation is she went 0 if you look at the net distance. The other one is if you look at the maximum distance she got from the house, well, she could have gone 10 kilometers total. That means 5 out, 5 back. And the last one is her legs says, hey, we ran 10 kilometers. So you have to be sure to ask questions about how good the question is and get the difference between distance and displacement right, because with the net distance, that can mess you up. Time. A measurement usually expressing in how many seconds have elapsed or the change in measure on a clock. We usually call it time, usually done in seconds. I have a whole long list of things you can discuss about what it is. For example, when you start with the watch on 0 seconds and you stop when it says 10 seconds, you say 10 seconds gone by. If the clock said noon at the beginning and says 12:15 at the end, you would say 15 minutes or a quarter hour has passed. Most probably need you to use it as 900 seconds, since that would be the 15 minutes times the 60 seconds. Seconds are based on how long it takes the Earth to actually orbit the Sun in 1 year, where the actual year is 365.2422 days, which leads to leap years and all kinds of confusion. For those who are truly curious, it works out to be 365.22, 2422 times 24 times 60 gives you the big number 31,556,926 seconds. Now, since we actually call it 365, then the numbers and days have to be account for the 0.224, which goes that a day is not as long as we think it is, and reality is time is a way we decide when to be there for lunch. We're not going to go through this too much, otherwise you just might hurt your head. Speed. Distance divided by time, which is a scalar. Velocity is displacement divided by time, which is a vector, making it more useful as you know which way to go and can predict things. Acceleration is a change in velocity over a time, and you need to know those definitions for the upcoming test. Change in is abbreviated as delta, which means the difference between the final value and the initial value. Delta t is t final minus t initial, for example. So the watch ends at 10 seconds and starts at 2 seconds. You say the time was 8 seconds for that event. We use delta for a lot of things like velocity and distance too. For example, when you drive to Salt Lake City, you don't say you started at mile marker 1 and got off at mile marker 23 to be downtown. You would say it was 122 miles from where you started when you took your exit before looking for parking. Problem solving steps. Step 1. What is the real question? Sometimes the initial question is not what you think it is, and therefore you need to go back and think about it again, such as I pointed out, the lady who was running from her apartment for 10 kilometers an hour for 1 hour, and she ran a straight line out and back, but you asked her how far she went. Her legs would say 10 kilometers. Somebody looking at a map says, hey, you went 0 because you're back where you started, and the other person might say, well, you got 5 out and 5 back. Those are 3 different answers, so be sure to ask the question. What's given you to for free? You make a list. Step 3. What mathematical representations in nature might apply to the situation? For those who keep forgetting what that is, that's these right here, and this is the laundry list that you need to make of what you need to do. Convert. Step 4. Convert to proper units. Move the letters around as you need to. Step 5. Stop and take a look at it again after you filled in a few blanks, because all of a sudden something might come to you and say, oh, now I give it to you. Often the change in time, change in distance and direction, velocity, are almost just given to you. Step 6, are there any assumptions you can look for, like you're on Earth, therefore the gravity is 9.8. Look for words like started from rest, which means initial velocity is 0. Look at your change in time to see if you're given a final or initial, and then repeat for distance and velocity. Now that you've taken care of the easy stuff, then you start in on the harder stuff. Once again, a review of, do you know what time final, time initial, change in time, what these letters and terms mean? If you don't, you're going to go crazy, and we will always be dealing with average acceleration here. We will not be having change in accelerations. That's for a calculus-based course. For those who've forgotten what the things mean, distance over time, this is what the formulas look like. Velocity average is actually add them all up, divide by the number. Usually we just have 2, so we said this. And you go through what needs to be done. If you don't know how to do that, please ask me more questions. Now we will go through some problems of how to